For this, let me invite Venkata Sainath. He is a research scholar in IIT Kharagpur. So he will be facilitating us, demonstrating us, or helping us in this hands-on practice session. Sainath, I welcome you.
Yeah, thank
Am
you,
I
sir.
audible to
Thank you.
you?
Yes, sir. Like your voice is audible to me, and I would like to know
Yes.
whether if my voice is audible to you and as well as all the
It
participants.
is. It is not perfect actually. Your voice. Uh, it needs some improvement.
Okay.
It is not clear.
Oh, I don't know. I mean, it was the same setup. Hello.
Yes, yes.
Uh, no, like
Participants,
the participants.
can you hear Sainath?
Yeah, participants. Please let me know if you can hear my voice clearly, or if you have any problem with my voice.
Yes, yes, they are responding. It is clear.
Okay.
So now the session is up to you.
Yeah.
You can start the proceeding.
Fine, fine. So like the participants won't be speaking much, right? Is it like that?
Yes, initially they will be in mute. So if they will have any query, they will be posting in the chat box. As and when needed, I will be interrupting you. So you
Okay,
can start the proceeding.
okay, fine, fine then. So yeah, I can see the okay, fine, fine. Okay, so good afternoon, everyone. So like as Professor Mahapatra has introduced, myself I am Sainath. Okay, I'm a research scholar from IIT Kharagpur. So although my background is from this production engineering, so BTech in manufacturing science and MTech in industrial engineering from IIT Kharagpur. So I am currently working on this image processing techniques, where I use the machine learning tools and techniques in order to detect like defects on pipelines, especially corrosion or cracks. So like I mean, as the title says, so today I want to give you a brief outline of how these machine learning techniques and as well as this image processing techniques they can be used in the manufacturing field, uh, to identify the defects. So and although like I mean this seems fascinating, like using artificial intelligence, using deep learning techniques for inspection in the manufacturing field, there's a lots and lots of mathematics and programming and many other issues behind it. So frankly speaking, it's impossible for anyone or even for me to give you an overview of all the tools and techniques from mathematical point of view in just like 1 or 2 hours. So today's session is mainly focuses on the hands-on experience. So I assume that you have some basic idea of programming and especially Python programming. So even if you don't have any idea of Python programming, still it's fine. So like yeah, I assume that you have some idea of programming, like what is a function, what is a class, and what is an object. And if you don't know, please don't panic. Still, the session will be smooth. And I won't be explaining much. Like yes, this is the theory behind it, and that is the theory behind it. You will type the code
Hello,
on
sir.
your own.
Voice is not clear. We are not audible, sir.
Oh, hello. So voice is not audible. Hello, like.
Uh,
Uh,
Actually, it is audible to me, but still means it needs some improvement. I don't know why it is not coming properly. Uh,
should I switch off the fan? I mean, will that help? Uh,
can you
can,
use headphone or Bluetooth sort of thing?
yeah, I can use the headset, no issue. But right now I'm
I
using the
think
webcam, and that is sufficient to. Okay, fine. So can the audience please respond again if my voice is audible or not, or whether it is clear or not? Like few more, I would like to listen from
for
few
me
more.
it is clear. For me it is clear. I don't know the other participants. If somebody is having some problem, yes, it's clear. They are responding. It's
No, like
clear. There is no
if
issue. You
most
can
of the
go
people
ahead.
if most of the people say fine, then I had to go on with it. I can't change for a single
Yes, yes,
person
yes.
or a couple of students, right? So I'm sorry for whatever is going on. Anyhow, so yeah, today it will be a hands-on session. So especially we'll be working on a simple data set called iris dataset, which I'll show you. And you'll be typing code on your own. So you have to type and you have to follow me when I'm typing it and when I'm running the things. and make like make sure that, see, this session is about information, like how can you use the existing tools and techniques to do something in the machine learning field. So, and yeah, let's just immediately start the work, and then like whenever you have queries, please answer it in the, please respond it in the chat. And yeah, exactly, Google Colab, one of the respondent has said that, shall we go with Colab now? Yes, we will directly go to the Colab. We'll solve a simple problem, and once while we solve the problem, when solving the problem, I would like to listen from you, then we'll go to the theoretical aspects. Fine. So I'll be sharing my screen with you now, and please follow me. And if you have any queries, just message in the chat. So just okay, let me share my screen with you. Listen now, your entire screen. Okay. Yeah. So please, so I think I have shared my screen. So I have shared my screen. Fine. So you just, there is something called Google Colab. I have no idea like how much of you are aware of. Just type Google Colab and make sure that you are logged in Gmail. Of course, since you are attending the meeting, you are already logged in Gmail. So if you type Google Colab, you will get something like colab.research.google.com. So just click on that. Just click on that, and then you will get something like this. Hello. So like it's very hard for me to track down like whether every person has opened it or not, but you will get something like this, and from then just click on new notebook. Okay. So if you have done till this much, then the setup is ready. If you just click on the new notebook, you will get something like this, untitled.ipynb, that is the heading, and then you will get something like this. So this is the starting step for writing the program. So, and again, I would like to know like how many of you have reached this point. Okay. If you have got this thing, all your settings are ready, and I'll give a brief intro about Colab in a couple of minutes. Yeah, please respond whether you have done it, whether you got it or not. Just by SSS a few more. Okay, that's good. Few more responses I would like to hear. Few more, because if you haven't started, if you haven't opened the notebook, then you can't follow me along, and that will be a huge drawback. Okay, fine then. Yes, it's fine. Okay, let's continue. I got some responses. Let's continue. So coming to Google Colab, fine. So yeah, Google Colab, you can say it's like an online platform where you can write your program in Python, of course, in many other languages also. So this Google, it will automatically give you some RAM, 12 GB RAM. It also gives you a GPU for free, graphical processing unit for free, a powerful one. It also gives you TPU, tensor processing unit. So if you don't have a very sophisticated system, and you may think that no, I need a like high RAM and high processor and all those things, and that is not the case. Using the cloud computing resources, you can still do everything online if you have a good internet connection. So this is, if you are not aware of it, and this is one of the tool where you can use and still get the things done. And I must say that many of my BTech project students, like they have worked on deep learning, machine learning on Google Colab only, and they have run it for 12 hours, 14 hours, 16 hours, and they got very good results as well. And not only Google Colab, there are some other platforms also. So as I said, I will be giving you lots and lots of information which will be helpful to you in the future. And especially if you're making a transition from or getting adapted to the new technology like artificial intelligence, machine learning, and as well as the data science. And I will also go as fast as I can. And whenever you have a query, please interrupt me in the chat. Yeah, not only Google Colab, there are other services also. Amazon Web Services, if you have heard of it. And besides that, Microsoft Azure. So these are some of the platforms. If you don't have enough resources, you can still use them and get your work done. Okay. So, and one more advantage of Google Colab is that some of the standard libraries, so whatever the functions you want to write, generally if you are doing it on your own system, you have to install the libraries and then import them. But here Google Colab itself has already inbuilt some of the most famous libraries like NumPy, SciPy, Pandas, and as well as sklearn, and even few more. So yeah, just to make you feel that you are a programmer and you are a coder, so let me just type this thing and I'll just tell you. Yeah, just type this first command. import numpy as np. Just copy. I mean, please type it. Okay, I'm copying, but so you write and make sure that you exactly type exactly like the small letters and capital letters, the spacing, everything has to be followed. And if you don't do that, you will get an error. Just type import numpy as np, copy, and then go to Google Colab, the first line. You type it, import numpy as np there, and then you can click on this button using mouse and or using keyboard. You can quickly go to shift and enter. So using keyboard, shift plus enter will run the command import numpy as np. So what is numpy? What is this import? So I mean, I just want you to watch it like a movie and go on with the flow. Don't make yourself burdened with so many things. And after like the session, you'll be getting to know many tools and technologies and some different methodologies. Okay, so that is the idea. And since this is the first line, it is taking some time, and you can see that it is going initializing. Okay, initializing, like it is importing the required libraries and few more things at the back end. That's not our, yeah, it is showing initializing Python 3 Google Compute Engine backend, right? So that is the first line. So yeah, hands-on sessions always slow, and you need to be patient. If you already know a few things, you need to make sure that all the participants are understanding and they are going with the flow. I have no idea why it is taking so long. Anyhow, let it load. So import numpy as np. So while it is loading, let me explain what is numpy. So, and I don't mind personally if you have your video on, I mean your webcam on, but anyhow, so I don't know. So let me explain what is NumPy. So NumPy stands for numerical Python. Okay. So all of you know MATLAB, right? And MATLAB stands for Matrix Laboratory. So whatever you want to do in MATLAB, of course you can do so many things, almost everything in the scientific field in MATLAB. So whatever you want to do inside, it has to represent as a matrices. So, and obviously, you know, MATLAB is very much expensive and licensed and this, that, and it is very slow compared to Python, C++. Many issues are there with the MATLAB. And this Python is like a free version, like a open source. And this NumPy, this library, numerical Python, it is such a powerful library. Just with one library, the Python becomes as much good as or as fast as MATLAB, even much faster. So whatever you want to do, like the matrices, linear algebra, inverses, eigenvalues, eigenvectors, single value decomposition, if you have heard of them, the principal component analysis, which we will discuss in the tomorrow's session, many things that can be done with this library called NumPy. So in the library, there are some functions, okay, and we'll be using those functions so that our algorithm becomes much faster. And I have no idea why this is taking so long. It should not take so long because NumPy is already inbuilt. Cell is already running. Okay, fine. So yeah, so that is the first line. And if it has been executed, you will get some two blocks here, which shows the RAM. If you go there, you will get two blocks where the initializing is there. And in one block, there is something RAM, 1.GB out of 12 GB or 2 GB of 12 GB, and also some hard disk space out of 100 GB. So Google Colab, it will give you like for free, like some of the RAM and as well as storage space as well. So, I mean, that's a very brief introduction, and you can do wonderful things in Google Colab and using TensorFlow. Anyhow, so it's already running. I have no idea. That is strange. Okay, let me cancel it again. I assume that most of you are able to run the first one, right? RAM and disk. Hello? Maybe all of you are able. Please restart. Okay. All of you are able to run the first time. Then I don't know why it is getting executed. It is taking so long. Oh my god! It never happened till now. I'm sorry for the delay. Both NumPy as NP. I have no idea. Anyhow, so yeah. Fine. Okay, let me quickly go to the problem statement while it is getting loaded. So yeah. it has become net slow. I have a good internet connection. Anyhow, so the title of this session is this getting comfortable with machine learning. So I'm sure that almost all of you have heard the term machine learning. So after this class, I just want to get comfortable. I mean, there are different terminology that you come across in machine learning. Something called training data or testing data, model, learning algorithm, pre-processing. So some of these terms I just want to become comfortable so that after the session, we will go back and start your own journey. Okay. So one second. The problem that we are going to solve is this iris dataset problem. So this is a standard problem. So assume that we have three different types of flowers. Okay. So here they belong to a particular class, iris, but they are distinct. So first one is iris versicolor, iris setosa, iris virginica. And coming to the machine learning, again, I'll keep on move from theory to coding, and again, it will be like a episodic way, but still you should be able to follow because like, yeah. So in machine learning, we fundamentally have two problems. So that is classification and regression. So I'm sure most of you have heard multiple linear regression. So under machine learning, you have supervised learning, unsupervised learning, and as well as reinforcement learning. So very in a crude manner, in supervised learning, you have input and output. So y equal to mx plus c is a supervised learning. Or a regression, y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus and so on. That's a linear, multiple linear regression. That's a supervised learning, where you have some input and some output. So from practical point of view, you want to have a mapping between the input and the output. So, and that's what we do in the machine learning, right? That's the supervised one. In case of unsupervised, it is like in case of unsupervised, you want to cluster the data. Suppose the audience right now, they are like different audience are like, they're in the meeting. Some of them are BTech students, maybe, I don't know, maybe PhD students, and some of them are professors. Now, if I want to put them into clusters based on some of their features, I don't have any output there. It is just a clustering process. For a simplistic sake, you can say that you have some data on a 2D plane and you want to join them as a clusters and find them the cluster centers, and then try to have some interpretations, and that comes under unsupervised learning. And coming to reinforcement learning, so if you have played chess and you want to do something you want to train the, all the like 32, 16 plus 16, 32 pieces are there, a set of rules, and with the given rules, you want to train your pieces in such a way that they can keep on, like, you can play the game. So what happens in reinforcement learning in a very crude manner, you play and then you fail, you get some reward, and then you change your action. So if you are aware of chess, if you have played chess, then you will know. How will you improve by playing again and again? You play, you make a mistakes, you will get lost, that is 0, and then you change your steps. And the same thing gets applied to while riding a bicycle also. So how do you learn a bicycle? You will ride and you will fall, or you lose balance or something, you make mistakes, and then you recollect it, and then you change your actions. So that's the reinforcement learning. Reinforcement is completely a different paradigm itself. Okay, so I don't work on that. But under supervised learning, or most of the problems in the manufacturing field, they are mainly focused on supervised learning. And under supervised learning, so if you take this as input output modeling, why? Oh, sorry. Yeah, input output modeling, we have y here, okay, and we have some x1, x2, x3. Those are the independent variables or the input variables, y as the output. Now, based on what value of y will take, okay, so I don't know how many of you are following. So based on the what value of y will take, we can divide this supervised learning into two problems, simply classification and regression. So from mathematics point of view, in case of a regression, y is a continuous variable. Regretting, y is a continuous variable, the height of the people, the weight of the people, the wealth, and so on, like that. Whereas in case of classification, y is a discrete variable. Simplistic case, whether I am male or female, whether I am alive or dead, or whether a product, in case of building, whether it is defective or not, or corrosion present or not. So it's called a binary classification, and this is a discrete 0 or 1. You can have multiple levels also. So suppose if it's like injury, maybe minor injury, major injury, and then fatal, and then nothing, zero. So you have like 4 different categories. So you have a number like 0, 1, 2, 3, 4. So this is a like standard classification problem. So and for classification problem and for like supervised learning problems, the standard library for Python is the sklearn. So let me also show you that. Yeah, finally this thing has done. I'm happy. So you can type sklearn, scikit-learn, SCIKT, scikit-learn. This is a very powerful to like library for Python for machine learning. Okay, so this is a scikit-learn. Okay, and we are actually we'll be using the scikit-learn today. And whatever you want to do, it can be classification, it can be regression, it can be clustering, unsupervised. Everything is there. You don't need to do anything. Even PC is also PC, principal common analysis also will be there. That is dimensional reduction. So it is as good as MATLAB. If you look at MATLAB documentation, like MATLAB also has very good documentation, and this documentation also as good as MATLAB. And yeah, so that's it. So under machine learning, under supervised learning, under classification, we are trying to solve one simple problem to have an idea what exactly goes in machine learning. Okay. So and again, I would like to know whether I'm going faster or I'd like to get feedback from the audience. Yeah, I would like to get feedback from the audience whether I'm going a bit faster. Should I slow down? Because I don't know how many of you are comfortable with what's going on. Should I slow down or is it okay? Yeah, a few more responses I would like to hear. Like, should I slow down or is it okay? No, she's fine. So far it is okay. Fine then. Okay, yeah. Again, my main motive is to give you more information than teaching you what is regression, what is classification in a mathematical sense. Okay, fine. So yeah, let's go to the PPT. Yeah, this is a standard problem. We have 3 categories of flowers, and we would like to classify them. Our eyes can classify easily, assuming that we have enough experience, right? And if we are using a direct image, that's a different paradigm, which again I will discuss at the end of the session only. Here, what we are doing is that we are extracting features from the image. Of course, assume that I have flowers in my hand or I have it beside me. I have some other sensor, and using some sensors, I am measuring. This is petal and sepal. Okay, the petals are the beautiful ones. If you look at other flowers also, the sepals are generally greenish in color. Not here. They support the flower. Okay, they support the petals, and most of you are aware of it. So sepal and petal, we are taking sepal and petal, and we are measuring its width and as well as height, length and width, whatever you want to call. So sepal, length and width, petal, length and width. So we would like to compute these two. 2 features for each sepal and petal. Total 4 features. We are extracting these things. Okay. The first step is the data collection, and in the data collection, this is the feature extraction. So how is it related to your problems? It is simply like you are conducting an experiment and getting the data. Suppose you are working on EDM or ECM or on some conventional like machine. You are doing something and getting the rate, MR or material removal rate, or surface roughness, or cutting velocity, or feed. Whatever the values, whatever is input and whatever is output, that is up to the problem. But whatever the numerical values we are getting, in our simplistic example, this is what the input data, this is what the information is. Oh, why is it immediately just okay? So the data that we are considering are 150 flowers. Okay, 150 flowers we are considering, and each flower has 4 attributes, 4 features. And what are those features? Sepal length, sepal width, petal length, petal width. Okay, and what we would like to do, we are given initial data 150. Okay, and we have these 4 information like sepal length, sepal width. We want to find a function which will tell me, now you give me a new flower and tell me what is this category it belong to, which category does it belong to. So then with those values of sepal length, sepal width, petal length, petal width, I will be directly able to say that yes, the new flower belongs to this category, and that is the prediction. And how is it related to your problem? You do whatever the data you do, develop the model. Like suppose I am a guy from industry, I will say that my process requires these parameters, and what will be the MRR, and I'm making this setup. what is the MRR? Okay, I just want to know, I want to get this MRR. It is the other way around. I want to get this MRR is material removal rate. Okay, or surface finish, that is a much more easier to correlate. Surface finish, say 0.7 microns, okay, or 0.78 microns. This is my Y value, okay, 0.7 microns. What should be the input parameters? So that is what I would like to know. I'm not an expert in all those fields, right? So it is always about building a mathematical function between the input and the output, and that we will be doing now. So this is the data, and then, and this is the, like, if you look at the data, and I will show you all the data in the Colab, Google Colab, everything will be shown. You need to be patient and follow it. And if you look at some of this data, you will see that the sepal length is ranging from 4.3 maybe centimeters or inches. I do not know the units. Okay, 4.3, 7.9. These are some of the standard data. Mean and max, standard deviation, and correlation. And if you have heard of correlation, that's Pearson correlation coefficient. Again, I won't discuss it now. So this is some of the information about what data we have. Even if you have conducted your own experiments, the data you need to look at how much, like, the voltage you varied, how much current you have varied, how much speed you have varied, like depending on the process you are doing. So it is important to have an idea what ranges you are dealing with, because whatever the prediction you will make in your own field, manufacturing or any other field, that is generally limited to the range of the data you are taking. Suppose you have varied the voltage from 250 to 440, just like that. And whatever the information, whatever the analysis you have, it is only limited to this range only. You cannot simply say comment anything on outside. Okay, so in general, it may vary. That is the case in generality. So yeah, let's now again start with the programming. And during the program, if you have any queries, and I will answer them. So I think the problem, the question we are trying to solve is very clear, right? We have some data set. We have images 150 flowers. From 150 flowers, we have taken the data, 4 attributes: petal length, petal width, sepal length, sepal width. And now I want to develop a model. So how does the model look like? We will see. Now, when you give me a new flower, I should be able to say which category it belongs to. Okay. So yeah. So let's go to the Google Colab and let's type something. The first one everyone has done. Import NumPy as NP. Now we want to make plots. And not to make figures, beautiful plots, you have a very standard library in Python, that is matplotlib. So just just copy this thing, or just type this thing and run it. Shift and enter. Import matplotlib.pyplot as PLT. Please follow the same convention so that there won't be any mistake. You can change the names also. Just try to follow exactly what is going on. Shift and enter. Okay. So now I'm importing matplotlib. This as NP, as PLT. I'm not giving very detailed instructions. What is that as and all those things. Our idea is to get an idea. Our motive is to get an understanding, a rough overview. Okay. I'm skipping those things. So now we have imported this matplotlib library for plotting. Now quickly. So that's the first one. That is the step one. We have imported the libraries. Now you may have your own data set on your own desktop sitting somewhere. So if you have your own data, you can read the data using this command. Okay. If you know the address, of this in your own PC where your document is there, .txt or .csv, like that, and based on that, there are some commands where you can read it into the space in the Google Colab. Okay. So, but now what we are doing from the library scikit-learn, the dataset is also already included in the scikit-learn library. For illustration purpose, I am simply taking that dataset. Okay. So please copy this line from sklearn import datasets. Control C. And you type it slowly. I need to be a bit slower, From sklearn import datasets. And anybody, if you have query, please type it in the chat. Okay. So now the data sets has been imported. And among that, there are so many data sets. We will be taking only one data set. Let me see if anybody is. You please share it in the chat box to copy.
Yes.
Okay.
what we can do, while you're pasting it in the browser, you can also paste it in the chat box so that
Yeah, I
they
can
can
do
also
that.
copy and
And
paste.
somebody is saying that I can share the PDF. Is it possible to share right now?
No, no, no. You paste the command in the chat box also while
Okay,
pasting it
okay.
in the browser.
Yeah,
You paste it
fine,
in the
fine.
chat box.
Okay. So, okay, I'll paste in the chat box. Okay. So, import. Okay, from SQL and import datasets. Okay. So we are importing multiple datasets present, and among the datasets, we will be choosing our for our example, load iris. Okay. Control C. Please share PDF, sir. Okay, so like I mean some some of the
No
content.
need to save the PDF now. You only paste the command
Yeah.
in the chat
So
box.
yeah, this is not a very lengthy program, okay? And we'll be
Yes, yes.
passing. This is a very
Hmm.
short program, and we'll be passing and we'll be discussing many things, okay? So just the participants are requested to be a bit more patient. Okay. So from the data sets, we are calling. You have to use this parenthesis, okay? You have to use this parenthesis. Iris. We are calling the data set iris. And again, after every line, you just type shift and enter. On cyclone, we are choosing many data sets, and one of the data sets dot load iris. Okay. So now, like I think these four steps are very simple, and I'm sure that everyone has followed it, right? So all of you have followed it, right? So I think if they switch on to the video and then should wave me using their hands, I think that will be better than. Is that okay, Professor Mahapatra? Will that be a problem?
What?
Like they can switch on their videos, right? I don't mind if they can switch on their
No
video.
problem, no problem. They can switch on their videos, but one thing, you just paste the command in the chat box, so they
No,
need to
no,
follow actually.
no, no,
They
that
need to
I'm
follow.
doing, but I don't know what they're doing and what exactly is going on. So that's something I feel like I'm just talking to nobody
No,
occasionally.
no, it's perfectly all right, no problem.
Okay, it will
You
register
carry
my
on.
that is true. That is true. But actually, I have very good internet connection. Anyhow, so fine, fine. So yeah. So after now iris. Now let's experiment. What is this iris? Just type iris and then click shift and enter and observe what is happening. Just observe. It is for you. Like you spend some time in observation also. Just observe what is happening and you can see what is going on. Okay. You can scroll down. Of course, when I'm doing also you can see. That is a much more easier option. Okay. So this iris, it contains everything about this data set. Okay. So initially, if you heard of dictionaries, okay, let me skip the programming part. It is describing what is this dataset, iris plant dataset. Okay, number of instances 150. All the data is already here in this simple iris. Writing 4 lines, you have already got the data to work on. And if you use pandas or some other library, the data will come in a beautiful format in colorful tables also. Okay, and this is this. I think all of you are having patience. The feature names, sepal width, petal width, sepal length, 4 features, right? And the target values are 0, 1, and 2. So what we are doing, we have 3 categories of flowers, right? One category we are labeling it as 0, another category as 1, another category as 2. The order is like Setosa, versicolor, and then Virginica. So they are in the order, okay? So this iris contains all the information. But in order to run a program, like in order to give, what we deal only with the numerical data. So what we will do, I'm just erasing this thing. You can have a look at it. All I want is what is X and what is Y. Our X are the 4 features for all the 150 plants. Okay, you have seen that big rows, right? That is nothing but the matrix, a big matrix. It's a 150 rows by 4 columns, 150 by 4 matrix. And also you have seen 0, 1, 2 in the target variable, right? So those are our y outcomes. So first we need to take it from the iris. And how do you do that? By simply I think you can write this x equal to iris dot data. This thing you should be able to type x equal to iris dot data. Just type it and then, well, let us see. We are taking the x equal to iris dot data. Let's type that. X equal to iris dot data. Okay. Again, shift and enter. So what is this x? I think simply again type x and capital X. Make sure that it is very case sensitive. Make sure that you follow the same things, and otherwise there will be an error. Let us see what is x. X is simply all the data that we want. All the 4 features for 150 flowers. And what is the dimensionality? From the problem definition, we know that our data has 150 flowers. It's a 150 by 4. And how do I know the dimensions? That is simply x dot shape. 150 comma 4. Okay. So there are 150 rows. It's the dimensions of the matrix. 150 rows and 4 columns. So my input data is this. Okay. And now, what is our output? For each flower, there is a 1 category. There are 150 flowers. So our output is nothing but a vector of values 0, 1, 2, and its dimension is 150. So let me again take that y also. Y, small y, capital X and small y. That is iris dot. And let me see, what is that? Target. Okay. The attribute is target. Again, shift and enter. Okay. And again, if you want to be confident, what is the actual dimensions? So this is a simple example, so it doesn't make a sense. But this dimensionality checking is the fundamental, is the first step in the programming. Like when you're writing big programs, okay. So this you have to always check your dimensions. That's the first criteria that your program is correct. Okay. So that y equal to iris dot target. So yeah. So now our platform is ready. We have taken x and we have taken y. Now we have entered to the mathematical field. Now I don't care what is x and what is y. I just want a mathematical function between them. And let us see how we are going to do it. So, okay. So we have inputted the data sets and then we got x and y. And then the step 3, training data and then testing data. So, yeah. And I want to slow down a bit. Although it's, what are the target values? What are these parameters? That's great. Okay. What are these parameters? Okay, fine. Let me answer it now. Some of them are asked. The 4 values are nothing but for each flower, there are 4 attributes or 4 features. Petal length, petal width, sepal length, and sepal width. Petal length, petal width, sepal length, sepal width. These 4 are the 4 parameters. Actually, we should not say parameters. 4 features. Okay. 4 feature values. Okay. And what are the target values? Target values are 0, 1, 1. We have three different types of flowers, right? For one flower, we are calling it as 0. Another flower, I am calling it as 1. Another flower, I am calling it as 3. Another flower, I mean another type of flower. Okay, suppose male and female. So male, I will call it 1, female, I will call it 0. For representing in a numerical way. So I think it is clear, right? What is x and what is y? So I mean, that is very fundamental and it is important. Okay, so hold on. And yeah, if you want to check y also, you can check y again. Y and then shift and enter, you will get a big list of that ones to solve those things. Are you able to follow? So fine. So that is the y. I'm deleting this. Yeah. So now our x and y are ready. Now what do we need to do? So in machine learning, okay, when you want to develop the model, when you want to develop a function, we need to check whether that whatever the model you have developed, whatever the function you have found, is it correct or not. You have some data and you want to develop a model. Of course, using the data, what is your intention? When new data comes, When a new flower comes, I want to classify it. I want to identify it. Not to ensure yourself that whatever model you are developing, it is robust and it has a higher accuracy. What we do, we split the data into two parts, training data and then testing data. Using the data we have, we split it like 80% and 20% or 90% and 10%. We split the data, and after splitting the data, we train it with the highest portion, 80% or 90%. And now, in order to check whether our model is correct or not, I will simply test it with the data which I have kept it in the black box, like 10% or 20%. Now, if it gives good results on the testing data, then I can say that yes, okay, fine, my model is performing well. So you have a data, you are splitting into two parts, you are training the model, you are developing a model using the data, and you want to cross check whether your developed model is correct or not. And for that purpose, you will be using the other data. Okay. So now, yeah. So you will not write your own function. So again, from sklearn, you can simply, I will copy this command and give it to you. So, one second. Yeah, fine. Yeah, please execute that line, whatever I have pasted from sklearn import. Simply like we are importing this function so that our life becomes very simple. Okay. I will explain each and every parameter in the program, don't worry. Yeah, please run those two lines. Okay, once you have run, I will explain everything just, and our whole session is dedicated for only understanding the program. Okay, so what we are doing here, again, I'm repeating, we have, I think it's better I have just give me, okay, just, let me explain a bit what is exactly is happening. Okay, so I don't know what is happening. Oh, my iPad is not working suddenly. I have no idea how it's not working. Can somebody say why this is not working? What happened to my iPad? Okay, fine then. So this X, the dimensions are 150 by 4. Oh my god, I think I can't go on my. Actually, I have an. I mean, I'm trying to use my iPad for drawing, but I can't get it done. Okay, let's go there. So we have this 150 by 4 matrix, right? X dot shape. So we need to split into two parts. Say 80%, 120 into the training data, and then 30 by 4 matrix into the testing data. And the same thing goes for Y also. We have 150 categories. So 120 will go for the training, and the remaining 30 goes for the testing. So this testing percentage, how much you want to train and how much you want to test, that is your own choice. Generally 10%, 20%, and as well as 5% are generally used. Here I just for the demonstration purpose, I'm taking 0.2. So 0.2, 20% of the initial data will be split into training, X train. That is the first parameter here. Okay. Hello.
Sainath, sir, it's giving syntax search overflow, stack overflow.
Yeah, someone is speaking. I can't get. Can you please type it?
Sir, it is giving search stack overflow.
What are you saying?
It is giving search stack overflow.
He is getting an error. It is showing such stack overflow.
See, Stack Overflow is like a website where you can go for search. See, if you have
Yes.
exactly, I mean, these are very simple lines. I don't know, like if you have executed exactly like this, and there should not be any error, right? I don't know. Let me shift and enter. Let me see.
There may be some spaces provided while typing or while copying and pasting. So you please repeat the step again, sir.
Okay, sir.
No, no.
Repeat it.
See, repetition of step. I mean, copy the same command.
Yes, copy the command and paste it again. Do it again.
Okay, fine, fine. So small y,
No,
small
no,
y.
no, sir. For you, it is right. But
No, it is small
see,
y.
for
Please
others,
remember that it is always small y. I am using small
yes.
y. Search Stack Overflow. But for what was the error? And one more thing, you should not give spacing also, tab. It should always start from the beginning of the line. There should not be any gaps. Hello? You should not give any spaces in the beginning of the line. It should always start from the beginning.
No, I have typed 3 times, sir. It's giving the same thing.
No, no. But before this thing, did you run this line from SQL and not model selection import like this? Did you run that command first?
Yes, I have run that command.
Oh, but I mean, see, these are, I don't know, like what is the error? I can only once I see only then I'll be able to respond.
Okay, it's all right. Continue, sir. Continue, please. Continue, sir.
Fine, fine.
Let it
So
be.
what about other participants? They should not be getting any issue, right? Like at least 3 more I would like to see whether it is working or not. Fine, fine. See, these are like simple commands, and I mean, I strongly believe there should not be any mistake because you're not even typing, you're just copy and pasting. But sometimes it happens, especially if you are new. So, fine. So, what we are doing is that we have X and we have Y. We have two matrices, okay, and we are simply splitting them. So, 2 will become 4, and that's what exactly these 4 variables are: X train, X test, Y train, and Y test. Okay. So, and I am choosing 0.2, the 20% for splitting. You can choose 10%, 5%, but to make it smooth, I mean, let's all use the 0.2 only for the time being. And this is the function train test split. And the arguments that we need to give are capital X and capital Y, obviously. Obviously, we need to tell the system what to split. We want to split X, we want to split Y. And in what ratio? That is test size equal to 0.2. There are a few more other attributes also, and again, I'm skipping that part. So after doing this, you can see that we have got training data and then testing data. And you can check yourself, X-train, dot shape, you can check. You can check the dimensions of the X-train. It is 120 by 4. Okay. And you can do the same thing for X underscore test dot shape. You will get 30 by 30 comma 4, 30 by 4. I mean, by I am saying that's matrix convention, n by n matrix, right? So the same thing goes for Y train and Y test. So you have the data, input and output, you are splitting them, training and testing. Okay. So that is a very fundamental step in machine learning. No matter whatever the algorithm people are doing in the whole world, everywhere, these are the fundamental and basic steps. They have to be followed. You can't skip them. Okay. So I hope stack overflow occurs due to buffer overflow. I don't know, like some people are commenting anyhow. So I can't resolve it now. So that's the thing. Now, coming to normalizing the data. Fine, okay. So let me calm down a bit. And before calming down, let me also show you what we will go. After normalizing the data, you all know, we have to train the model. We'll choose one model, say regression, not regression, similar to regression, and we'll simply train the model and then test the model. Okay, and that's it. And that's it. We are done. There is nothing here happening. These are just printing only, print function. Only 2 more steps before we finish the program itself. It's a very simple program. But again, we will see. I mean, okay, so that's it. After that, if time permits, I'll talk about logistic regression and linear regression. Anyhow, so fine. So it's a very small program. Don't panic, and you can do it on your own also. So step 5, training the model. Yeah, normalizing the data. Till step 3, everything. I hope everything is fine, right? Simply we are splitting the data, training data and testing data, 20%, 10%. You can change that into 0.1 and check the dimensionality again. You can play with it. So here from this, it is not only what you need to focus that in the libraries, there are already so many inbuilt functions that you literally have to do nothing in machine learning. If you know the theory and if you know bit of programming, all the functions, all the examples, everything is available. And if you are making a transition to programming Python or machine learning or AI, then this is the best time. Okay. So simply using this train test split, this is the train test split, and then you give the arguments x data, y, I mean the independent variables, y target variables, test size, you will get it done. So normalizing the data. So yeah, it's only 45 minutes, and we have already almost 2 hours or even 1.5 hours more. So any queries till now? I would like to answer. Can you type the step 3 commands? Okay. Step 3 commands. Should I copy it again? It is already there. If I am doing it again, it will delay you. I don't mind. Okay, you want me to? Somebody has said that I need to copy it. Can you type? I have entered it again, the first line. Any queries? I would like to get some questions if we have, because we have only like the code is very small, and I would like to answer your queries now. Please, you can ask or you can even type also. Professor Mahapatra, is that okay? Hello. Hello. Professor Mahapatra, are you online?
Yes, Sai.
Okay. Fine.
It is okay, no problem.
Yeah, because I mean, I just want.
Let us wait for a minute so that if they have any query, they can rise.
No,
Then we can move forward.
Yeah, step 4. I have not finished step 4, right? I'll talk about it. Step 4, I'll talk about it. I'll say a bit of theory or. I mean, step 4, I will talk about it. Just where is step 4? Yeah, I will talk about step 4. It is not completed. Okay, someone was saying. Step 4 is not done. Hold on. Okay, fine. Any queries? Maybe I mean at a basic level, what is machine learning or some of the queries if you have. Let's talk for a while. So there is no requirement of data pre-processing. That's great. So one of the comments you can see right now. Let me talk about it a bit. So there is no requirement of data pre-processing. Now let me tell you, data pre-processing, data acquisition. I mean getting the data, and after getting the data pre-processing is the biggest hurdle or is the biggest challenge. In fact, the most skillful work in the machine learning or data science or whatever you would like to call. Okay, so that is the most important thing. And suppose in your case you are doing some experiments, maybe SEM, scanning electron microscopy or TEM slots. Okay, I mean I don't deal. I came here from the okay. I'm not dealing with those things. It will take you lots of time to conduct the experiments, to get the appointment, many things done, right? So data acquisition, data processing are the most important things, and but I'm not discussing them right now. We assume that the data is given to us because data pre-processing is based on the problem what you are trying to solve and what is that. There is no commonality among all the problems. So that is why I'm not discussing, and this session is not meant for that. Data processing is not required here, but it is the most important, it is the most challenging and the most difficult task. Okay, and whatever we are doing normalization in one context, that can be perceived as data pre-processing only. Okay, so this normalization is one of the data pre-processing techniques. You may think like that. Since you said pre-processing, one of the student has commented, Just let me show you. See, you can see pre-processing is so important. Regression, classification are like the methods. Pre-processing is so important. It has its own domain itself. Pre-processing, feature extraction, normalization. Can you see it on my screen? Pre-processing, feature extraction, normalization. And in fact, if you want to do pre-processing, you require lots of insights. You need to have some mathematical understanding, some insights. What is the data about? How did you extract? So much of understanding is required. And it's a very skillful task. And again, that's not our concern at this point. So yeah, so I'm moving on. One more query I would like to hear from the audience. Anything related? Hello. There must be many queries.
I think we should move forward. They all are doing it, so we can move forward.
Okay, fine then. Okay, I'm moving forward to the step 4. Okay, and of course that is related to pre-processing only. Okay, normalizing the data, and once we have the data, so the data will have the ranges, the minimum value, maximum value, they may be different. Suppose you have 4 variables, x1, x2, x3, x4 in general. So x1 may have a different range. It have only positive values, maybe age. Okay, and the other one may be weight or maybe wealth. Wealth may be negative if you are indebted. So the range may be from 0 to 10,000. Other range is from 0 to 100. So if you take x1, x2, each variable, the ranges are completely different, and they may follow a different distribution altogether. Okay. So one basic concern, the range of the data is vastly different. And second thing, the distribution each variable follows, if you heard of distributions, the most famous example is normal distribution or uniform distribution or other distributions, exponential distribution, anyhow. So the data follows, each variable may follow a different distribution. Not to bring them into the same scale, say between 0 to 1 or -1 to +1 or in the same range. So we do some sort of pre-processing, okay? And you can do many pre-processing. One simple pre-processing is that if you have a data, suppose one variable x1, petal length, you have all the data. You divide each of the value by its maximum value in the data. Suppose maximum value petal length is say 4.5. Divide all the values by 4.5, then obviously they will be scaled down to 0 to 1, isn't it? So, and that is one way of normalization. And we have other ways also, something like if you know the minimum and maximum of the data, x minus x minimum by divided by x max minus x minimum. Okay, this is one way of normalization, and by doing that you will become 0 to 1. The range of the data comes to 0 to 1. But here we are using another normalization technique that is called standard scalar. And again, what is the standard scalar? Okay, since I'm not able to type, so let me, standard scalar is nothing but, it is nothing but the standard normalization. So if you know the normal distribution, Z, standard normalization, Z is nothing but x minus mu by sigma. Okay, so maybe I should show you in the Colab only. That may be better. Let me show you in the Colab. This is the Colab. Let's go to Colab. Okay, let's go to Colab, and let me show you what is X-train. Okay, this is the X-train, right? You can see it's a 130 by 4 matrix. Okay, so the first one, if I assume that is a petal length, so the whole, if you consider all the values, you can take the first column and then compute its mean, compute the mean of it, and also compute the, I'm typing it, standard deviation of it. Okay, once you compute the mean and standard deviation, what you do, you simply type hash indicates comments, nothing will happen. First you compute mean and standard deviation. Yeah, I think I can use this thing. Compute mean as well as standard deviation for a particular column, and then that variable x, whatever the value, 5.57, minus mean, And if you divide the whole thing by standard deviation, that is nothing but the standard normalization. STD, I am calling nothing but the standard normalization, standard deviation. Obviously, all of you know, okay? Here, right? X minus mu by sigma. So you will be doing for each and every, you will be doing for every column. For the columns, you will do it respectively. Then you will get a different data. And again, we will see it again. We will see it in the program only. Shift enter. This is nothing but the comments, they will not be executed. If you want to make a comment, you can use this hash symbol. So did you understand standard scalar? Standard scalar. We have the data. Every column you compute the mean, compute the standard deviation. For every variable, x minus mu by sigma. X minus mean by sigma, that is the standard scalar. We are importing that function from pre-processing. Okay, that library we are importing. And from this, I mean, we are again calling this, we are creating an object. And again, xtrain, xtest. So I will be copying these things and pasting it in the Google Hangouts. I mean, sorry. I'll be pasting it in the chart. Control C. Follow along, follow it. We could not see your screen. Is it? I don't know. From Escalon. No, one of the participants. One of the participants. Okay, okay, fine. So I have pasted one command. I mean, one line. Please copy that and execute it. I'll be copying. I'll be copying the other one. Okay. No, perhaps. Okay. So if you know classes and objects, that will add, but still without that also you should go on. So that is the second line. And then the third line, let's execute. Control C. Okay, execute it, third line, and execute the fourth line. Okay, fine. First we execute the first three lines. Standard scalar. And once you execute, you can again check what is extend values, and you can check extend value also. You can play with it while I'm going slower. So we have platform is this. Syntax error. How is that? Is everyone getting the same error? Perhaps the guy was getting the same error maybe previously. Strain equal to standard scalar dot fit transform x. Okay, sorry. There is this. Okay, extreme. So all of you are able to run these three things. Please have a look at the parentheses. Sometimes the parentheses, I think they are getting missed. Okay. Yeah, X-train, exactly. That's good. Sorry. Yeah, okay. In the X-train, like before X-train, before X, there should be a parenthesis. And okay, Okay, let me again copy from here then. Control C. Just don't blindly follow it. Have a look at what is going on. I think the one guy like who reported that in the beginning he has some issue. I think it is the same problem. Maybe. I don't know. Okay. So let's train. I have like pasted the command again. You can copy it and run it again. So what exactly is happening? And I mean I'm repeatedly saying it. So we have the data, but the ranges are different. In our case, it is a very simple data, lengths of the petals and all those things. Okay. So it is in the same range. You may have some other data, say voltage and current. The voltage range and current ranges are completely different, right? The units are different. So how do you deal with that? So there in such scenarios, this pre-processing becomes very important. Okay. So now you observe how the values are extended drastically modified. Okay. Just type extend and then see. Let us see what happens. You can see even you are getting negative values also. Can you see that? All of you can see my screen, right? So if you execute those 3 lines, the training data has completely changed into a different, how you may get surprised that the negative values are coming. So that is because x minus mu by sigma, mu is a fixed value for a particular data. And if x value is less, x minus mu will become negative. Very simple logic. Sigma is a non-negative number, standard deviation. X minus mu, if x value happens to be less than the mean value, the values will become negative. I think it's clear, right? So that's how you transform the data, x minus mu by sigma. So I'm just deleting this. So all of you are following me, right? And you can also do x test also. If you want, you can check for x test also. You'll also get the similar thing on. Of course, we are not done for the x test, sorry. When the results are random, whether the results are random values. No, results are not random values. Sorry. Where the randomness has come into picture. Purna Sethi, Mr. I don't know, like Purna Sethi. So whether the results are random values, the results are not random values. For each and every column, the algorithm has computed the mean. It also computed the standard deviation, and then has applied the simple operation x minus mu by sigma. X minus mean by sigma for every value it has applied. After that, the values have transformed to those values like which you have seen a few seconds back. Are you getting? This pre-processing is very, very important. And what type of pre-processing is required, that depends on the problem. Okay, problem and as well as the algorithm that you will be choosing. So, is it clear? So the results are random. Your answer and my answer is not same. See, I have. Okay, that random. Fine. Now we have to enter another topic now. See, just hold on. Yeah, I understand. Yeah. Punasethi said that whatever the matrix I got and whatever the matrix you people have got. Okay. Perhaps they are not exactly the first row and the first row, last row and last row, with the middle row, 10th row. They're not exactly matching. Okay. That's what one of the audience has said. Yeah. See, what happens is that there is something called random number generation. So in MATLAB also there is a random function. Here also there is a random number generation functions. So in splitting the data into training data and testing data, so there is a pseudo random number generator at the back end. So what it does is that it randomly shuffles all the 150. We have initially 150 rows, right? 150 flowers. Let's take flowers. Okay, we have initially 150 flowers, right? So it randomly shuffles those 150 rows or 150 flowers data, and then splits them into 120, 30 training and testing, because we have chosen 80%. Now, depending on the system, depending on the random number generator, and specifically saying depending on the seed value, there's a term called seed. You may look into it later. I'm just typing the term seed value. Okay, seed value. Okay, you just type it. You look into seed value in random number generation later. Not now. Depending on the seed value, and also depending on depending on the algorithm, it also chooses the the system's time. Based on many things, it randomly randomly gets this 120, 30. It may be different for every person, but what needs to be guaranteed is that the corresponding y values are same. Are you getting? The corresponding label. See, there are 150. I take 120, I give you 30. Now another guy has come. I take 120, I gave him 30. So the splitting may be okay. The splitting may be okay, but the corresponding output variables, they should be the same. So by random you mean that the 150 data into 120 and 30, yes, it is random. Okay. But if you want to keep it fixed, there is another method. You need to fix the seed value and some other values also. Then it will come everywhere in the whole systems. Okay. So I hope I answered Mr. Purnasheti's answer, question. Fine. It may be different, but that will not prevent us from learning the algorithm. So X train equal to standard scalar fit transform X train. So that is the training the data. So now just execute the last line. X test equal to standard scalar, control C. Let's see, just hold on. Apuna Sethi, I think it's good to me. Yeah, now we are doing the same thing for testing data also. We are normalizing data also. So fine, the step 4 is done. We'll discuss again the program multiple times depending on your queries. So the normalizing the data is done. Okay, the step 4 is done. Now I'm going to the next step slowly. That is training the model. After you train the model, simply you predict it. That's it. Only 2 steps more. That nothing much. Nothing, not a difficult task to do at all. So any doubts? Any doubts? Any query? I mean, once you raise a query, then I'll be giving you lots and lots of information, but I would like to hear from the audience. Fine then, now coming to the choosing the model. So depending on what you want to do and depending on the problem, the constraints, other issues, you need to choose your learning algorithm. Okay. So if it is an input-output modeling, your output variable is continuous. Okay. Then you can go for techniques such as regression, multiple linear regression. If your output variable y is a vector, if you have multiple outputs, with both MRR and surface finish and something, maybe some other value, 3 more variables, then you go for something called multivariate linear regression. And that is in the regression set. Even in classification also, in classification it is hard to decide which algorithm you have to choose. You have to go for the support vector machines or decision trees or even some methods called deep learning methods. It's a very difficult thing to do. What most people do is that you apply one algorithm and then check how it works. When it is giving good results, you keep it. If it doesn't give you the good result, then you go for another algorithm. And that's what people do. And if you have some experience already, like how different algorithms works, what are their assumptions, how the input should be there. If you have some experience, from experience also, you can choose the algorithms initially in advance. Okay. So here for simplistic purpose, we are choosing an algorithm called K nearest neighbor algorithm or K nearest neighbor classifier. In a short form, K neighbors classifier. Okay. So what is this K neighbors classifier? So K neighbors classifier goes like this. So I mean, most of you have heard this quotation like, tell me your friends, I will tell what you are, right? So your character or knowledge and everything is decided by your friends who are very proximate, like who are very close to you. So here, how do we identify a particular flower belongs to a particular category? We will check what are the nearest flowers to this flower. If there are more number of flowers belong to a particular category to this flower, then we will assign that class to this flower. So It is like, yeah, let's go to our problem. Let's go to our problem. So, I mean, for simplistic case, say you have a two-dimensional data and different data, they belongs to different categories. Okay. Maybe I should explain this algorithm using internet. That may be better. K nearest neighbor. Yeah, excellent images have already come. Yeah, so all of you can see it, right? So for example, let's take this example and understand this K nearest neighbor algorithm. So I'm talking about this. The blue boxes, they belong to one category. The blue square boxes and the orange triangles, they belong to another category. So it's a two-dimensional data, X and Y. Okay, they belong to one category. The red belongs to another category. So defect and non-defect. Welding defect present, welding defect non-present, not present. Now, when a new sample welding specimen or some other specimen has come, I want to decide which category it belongs to. So the easy way is that what we do, we compute the distance from this new point. The new point is nothing but the greenish one. We compute the distance from this point to all the points in the data on the plane. All the points on the plane. Each point corresponds to a particular welding specimen or some specimen which has a particular label, whether it is defect or not. Okay. To compute all the distances, now we have to decide what is the K value. How many people you want to take reference? So maybe 3 people or 5 people. Suppose I say that I will choose a 3 as my number, 3 neighbor classifier. First, I will find out 3 more specimens which are closer to it. And in the proximity, I will see that there are 2 orange specimens and 1 blue specimen, right? So since there are 2 which are closer to this, I will identify this thing as it belongs to orange category. Is it clear? Suppose orange is failure, defect. Blue is not defective. So since it is closer to the top 2, out of 3 best in the small circle, the 2 belongs to the failure category. I will say that this specimen also belongs to the failure category. So is it clear? Now the question comes whether I choose K equal to 3 or K equal to 4 or K equal to 5. Depending on the K value you choose, it may happen that your result may be completely different. Suppose in the same example only, if you have chosen 5, a bigger circle, a dotted circle, if you have chosen 5, among the 5 most nearest points, 3 points are of blue category and 2 points belong to the orange category. So now we will classify it in a different way. So this is the drawback of this model. This is the drawback of the model, whether 3 or 5 or 7, which has to be chosen. But still, this is one of the most common, commonly used classifier in even applications like recommendation systems on Amazon, on Flipkart. Okay, you get some recommendations, right? There it is massively used. Nearest neighbors. Is the algorithm correct? Is the algorithm clear to you? Okay. Yeah, I would like to listen from the audience. How does K nearest neighbor works? There is no mathematics much involved in it. We have the data. If it is a two-dimensional data, you put it on the 2D plane. If it is a three-dimensional data, you plot it. If it is a four-dimensional data, even if it is four-dimensional or five-dimensional data, you can still compute the Euclidean distance using the standard formula. And among all the distances, you put those distances in the ascending order. And when you put the distances of the different points in the ascending order, choose the first K values, say K equal to 3, K equal to 3 or K equal to 5. And among the chosen 3 or among the chosen 5, now observe those 5 points carefully, which category they belong to. The majority category the points belong to. You simply say that this point also belongs to that category. Okay. So I want to judge someone as say whether maybe rich or not, or intelligent or not. I look at his close 5 friends. If I take K equal to 5, out of his 5 close friends, majority of the people, they are doing what? Okay, are they rich or intelligent or whatever? Okay, studious. So and then I will classify him also to that category. So so that's how this K nearest neighbor algorithm works. Although it's very simple, It is one of the most powerful and widely used techniques. Is it clear till now? From sklearn, import k neighbors classifier. So yeah, I would like to hear from the participants. K nearest neighbor classifier algorithm, is it clear to the audience? It's very simple. No mathematics, no all those things. Eigenvalues, eigenvectors, and all those things. Okay. Fine. So once you know, again, let's execute it. Like this, there are so many classifiers. Support vector machines, decision trees, random forests, many other things. Let me simply import the classifier. I don't need to worry about the whole programming. The program is too simple in Python, and especially using powerful libraries like sklearn. I'm copying it here. Just copy it and run it. Shift enter. I mean, if you want to run it. Okay, just execute these three things and it's almost done. The programming part is done. And we'll go into the deep whatever we have done. What are some of the subtle aspects in the simple program? And again, based on your questions, I will go into much deeper. So these three lines you execute like I have done here. And okay, so from sklearn.neighbors, we are importing one of the classifier. There are so many classifiers. Okay. And once you choose, we have to decide the number of neighbors. They will be choosing 4 or 5 or 3 or 7 or whatever. But I am choosing 4. You can give any values also. Then at the later stage, the accuracies will be different. Of course, we'll be changing these parameters at the end. Okay. So, and after calling this algorithm, now for this algorithm, we have to give our data. You can give you different data. I can give my own data, any other data. Dot fit the CLF, FNN, CLF I am using for classifier to say it is a classifier. Dot fit in the parenthesis you give extend comma y train. Okay, and you have to run shifting. Enter. So this is the now by doing this, we have already trained the algorithm. We have already trained the algorithm so that it will predict when a new data comes. This is something called developing the model. Okay. So now what we do, we want to check this step, CLF cannot extend wide train. This does the training the model. So maybe somewhere you heard that not to train my model, it is taking days, hours. What they mean is that, this small step only. After choosing the classifier with appropriate parameters, and after giving the data, it will find its parameters. It is taking some time, and that is this training. And you might heard that training for, it comes in the news also. Somewhere like few years back, I heard Facebook or some Google, they have developed some software where the computers are talking to them in a different language, which the people cannot understand. So I don't know like how many of you have gone through it. And this is very much common in reinforcement learning techniques, where, and you know this Deep Blue, right? Deep Blue, if you know chess, that has defeated the Gary Kasparov, the world chess champion, and even AlphaGo also. That is one of the AlphaGo champion also that has been defeated by recently this reinforcement learning. That is also IBM Watson or yeah, some. I mean, so that's what they do. This step is the training step, and if you want to do the training, you want to have huge amounts of data, and that will take days, not for it to be trained. So this is the training step, and after this, once your model is ready, you want to again ensure that your model is ready. So for that, we have already separated our data into two parts, right? Training data and as well as testing data. Now we take our test data and then check how good, how robust is our classifier, our model. And that's what we'll be doing in the next step. This is the testing the model. So this is what it is. Control C. And I have to. What's happening? Okay. So Control C. Then. Is there any difference present between the writing the code in a block and in multiple? No, it is not. I mean, processing time. See, okay. I'll just answer shift enter. Okay. So yeah, one of the query you can look in the comments. Is there any difference present between the writing the code in a block and a multiple block in terms of processing time? See, I mean, although the question looks very simple, I have different results from it. It's okay. You may have a slightly different results, no issue. As one of the participants said, the random values the system chooses are different. Not an issue. Still, not an issue. It's fine. Here you are learning the process. Don't focus much on the numerical value and the accuracy. What are the different steps in developing a model, an algorithm? That is your emphasis. Okay. So no issue if you have different results. And coming to the question, difference between writing the code in a block and in multiple blocks in terms of processing time. So, see, I mean, I can't give a pinpointed answer. Yes, there will be a difference, definitely. If you're running it simultaneously, okay, it will have some difference, but those details which go in the back end, I need to have some understanding how the Google Colab works inside. Okay, so those details I do not know. I'm not a CS guy, I'm not an expert in that. It actually depends on how the Google Colab at the back end works, how they process it. So those details are generally not known to the outside people, but there will be a slight changes. But it is very minute that whatever the algorithms, the programs we write, it is not that much significant. That much I can say. There will be difference for sure. For example, suppose in one block if you are writing it, but we are both working on the same data set, right? See, there are 150 flowers. Okay, I will close my eyes. I split them into 120 flowers and 30 flowers. Every time I close my eyes and every time I split them into 120 and 30, those 120, those 30, they will be different. It's a random way of splitting. Are you getting? Hello. Pushpalata K. Every time I'm splitting 120 and 30, they are different. So that's what the difference makes. It is possible to make the same irrespective of the system, irrespective of it, which I have not done it here. Okay. Fine. So let's please copy that line. VKNN predict pre-RED test equal to CLF dot pred X test. This is our what this is doing is that now we have CLF has developed a model. It will take any vector, or even a matrix which has the 4 attributes: petal length, petal width, sepal length, sepal width. If you give me those 4 values, it will say whether which category it belongs to. Are you understanding? Okay. So if you remember what is X test, let me show it to you. What is X test? X test is nothing but 30 flowers which you have put it aside to check for the data. There are 30 flowers. It's a 30 flowers, right? 30 by 4 matrix, right? For each and every row, it is classifying which category this flower belongs to. The first flower belongs to 0 category. The second flower belongs to the 0 category. The third flower belongs to the 1 category. And that's what it is saying. Are you getting? So by doing these simple steps, we have developed a model. When you give me a new, so in order to make you more comfortable, okay, I'm deleting this. When you give a new flower, it will automatically say which category it belongs to. Are you able to follow? Now you give me 10, 20 more flowers. Okay, now my training is done. So somebody gave me 20 flowers. When I say 20 flowers, for each flowers they gave me the 4 attributes. Okay, and it is a 20 by 4 matrix. Once they give me this 20 by 4 matrix, I will simply put the matrix in this command here. Okay, Control C, Control V. You can simply replace test with the train. I will simply put that matrix here, and I will get the actual results. And if you want to know the results, so this is the way. This is the way like the model is discriminating or identifying each flower. So, in fact, now the next step is that this is the testing the data. Now we also want to train that. We want to check like on training how it is performing. Although we know that like it obviously it will give 100%. This algorithm will give 100%. The other algorithms may not give 100%. What is this training the data? After getting this classifier, we are also predicting what the X train will say. What will be the outcome of this X train? Which category the 120 flowers belongs to? And that's what exactly I have done here. Okay, where is it? Why KNN PRED train equal to CLS KNN. Okay, let me copy and paste it. Control V. So, and you just need to replace test with the train in the above command, or you can take my command. Okay, my whatever I have pasted. So with this, we have already developed the model. So again, now let us check how much accuracy we got. So how much accuracy? 90%, 95%. We always want numbers, right? So, and in order to check, what do you mean by accurate? If it is 1 here, you should say it is 1. If it belongs to second category, you have to say 2. I mean, it is the matching the label. That's it. That's what is the accuracy. The more number of matches you have, the more is your accuracy. For that simple thing, you need not write your own code. We can also import the same import function called accuracy score, and which I'm doing now. We can also do that. From echelon metrics, you have so many metrics, not only accuracy score, there is the precision, there is recall. There are so many other metrics which there are different ways to say how good a classifier is, how good an algorithm or how good a model is. So one of them is accuracy, direct. So we are, for simplicity, we are importing that thing. And then we are checking like how much accurate our developed algorithm is. Let us see that. accuracy score, and these are the two arguments, yk and pay test, comma y test. Okay, shift enter. Control C. Yeah, you can copy that. I hope so you can copy whatever I have pasted there. And then now let's print also. You can, I mean, of course, you can also do the same thing for this. First, let's look at our testing accuracy. Print. Print is the first thing we learn in C programming, right? What's happening? How is it possible? Okay. So my testing accuracy of K and model is 0.9. Okay, sorry, I have to copy it and paste it. So this is the last line, important line. We have two more lines which are similar to the above two lines. So print testing accuracy of KNN model. So if you type this thing, you should be able to get, I mean, 0.9, I got 0.9, you may get a different thing. Okay, don't worry. Let's not worry about the numerical values. So this is how you develop a, now again, let me repeat. Now you give me the data. I will simply use this CLF dot KNN, CLF KNN dot predict. Dot predict is the command. Now whatever the new data you will give, the X vector or array, so many values. If I do it here, okay, then automatically it will return which label it belongs to, which category the flower belongs to. Are you getting? So actually this is what is there in the deployment. So we have printed our accuracy for the testing data, which is very important. And you can do the same thing for the training data also. You just need to replace the test with the train, or I will copy the lines and show it to you. Just wait. Okay, but this is important. How many of you got some accuracy more than 90 or around 80? How many of you printed this testing accuracy of KNN model is 0.9? Yeah, please respond, the audience, because this is almost the end of the program, not the session, the end of the coding part. Now we will discuss much different aspects. Oh, somebody got 96.667, fine. Wow, that's great. 0.933, that's great. Okay, testing accuracy of KNN model is okay, that's great. Fine. Yeah, so all of you are getting different values because the way we split the training data and testing data are different. Okay. So if you look at any research papers, if there are any research scholars here, they will say I got this accuracy, that accuracy, then this is the final results. And you can make beautiful plots also using matplotlib. I mean, that's a different thing. So this is how one develops a learning algorithm. And the algorithm we have chosen is a k-nearest neighbor algorithm, and that is too simple and simple for understanding yet powerful. Okay. So, and whatever the commands you have done, let us do it for the testing like yknn predict dot training data. I think I have already run this thing, right? I think I have already run it. Let me run it again. We'll see. Okay, I'm just let us also do it for the training data, and I think we will be getting that. We will be getting 100% accuracy, hopefully. Control C. One, we are doing this, repeating the same thing for training data. In this special case, when we use this algorithm, you will see what happens. Like, okay, steps. Oh, we have already run that. We have already run it. Sorry. That thing we have already done. But still, even if you do it repeatedly, nothing will happen. You can simply replace the test with train in the above 2 lines, or you can, I mean, I'll be pasting it, you can copy it. I think you should be able to do it on your own also. You replace the word test in the above 2 lines. Like here 35, 37 you can see, right? There you will simply replace test with the train, you should get some accuracy. But I will be pasting them also. You can just wait for a while. Control C. Okay. So sorry, the training accuracy of the KN only is 96 point something something I'm getting. Okay. So if you print that, you should also get something. Let me copy this line also and print for you. Test it. Okay. So yeah, now the programming aspect is completely done. Now we have to understand what we have done, and we have to expand our knowledge, whatever we have gained from this small session, especially to our fields and our problems in the manufacturing sector. So please, you run. Oh, see what is this? See, I can see that some people are getting errors. Maybe it is because of the spelling mistakes, train test. In that error, wherever I see the test is written as a TS like that. See, there should not be any mistakes if you follow the exact statements. And I'm sure the PDF will be shared to you. So you can copy the lines and there will not be any mistake at all. Okay, there is no installation, there is nothing. You copy the lines and paste it and it will work. Because already CLF cannot predict is showing an error. For predicting, inside the bracket you have to yeah, variable name I change for my convenience. Yeah. If you change some things for small things, there will be small mistake somewhere. So let's not discuss those things, okay? So I think Pushpalata, okay, it's fine. This Purna Seti is showing error. CLF cannot predict that function is showing error because inside you have to give an array or a matrix of the input of the like of any matrix of size say m by 4 columns and m rows. Okay, then it will see, you need to say you need to show it so that it will classify. If you don't say anything, how will it classify? You need to show a flower, then only the model will say yes, this flower belongs to that category. If you are not giving any input, how will the model will answer? Anyhow, so yeah, fine, that's fine. So from now we have finished the programming aspect, but yeah, singleton array cannot consider a varied collection. Okay, some errors will come, like there should not be any errors, that those errors like we have to deal offline or you have to resolve on your own later. The result is not important, the numerical values are not important, the process is important. Once you get some value above 90 or above 85, it is done. It means you have developed a model. Okay, so don't worry about the result too much. Okay, so yeah. So now it is done. Okay, yeah. So now, although you may not understand inside exactly what is happening, you can proudly say that I have trained a machine learning model, say k nearest neighbor, or if you know something called logistic regression, and it has got accuracy of 90%. And if you are a researcher or if you are even a BTech student, your projects, you can say if you do this small thing, you can write on your resume or you can have your own confidence that I have developed a model, I have trained a model which will give an accuracy of 90% or 85% or 96%, like in this case. In other words, you can say I have designed a classifier also. So, I mean, this is what the developing an algorithm means. So, yeah, I mean, yeah. So that is the programming aspect. Okay. So before I correlate it with the actual problem, the title is developing a machine vision system for corrosion detection. Right? Corrosion is like a very a serious problem. It is a $1 billion issue if you are aware of. Okay. Of course, there are many other ways to resolve corrosion also. But one way is always through cameras. Cameras are there everywhere in surveillance. Okay. In space exploration everywhere. From images, I have a defect, a welding defect, a crack defect, or some bead, some other defect is there. Now I want a camera and I want to identify the defect. How can we go? Especially in the manufacturing sector. And one problem I will be discussing now is corrosion detection. Okay, it will be a superficial understanding because if you really want to have an idea what exactly is corrosion detection and all those things, you need to understand image processing a bit. So now, since you are not exposed to that image processing and corrosion, I'll give an overview and I have the PPT as well here with me. But before I go to the corrosion detection and explain you and relate the corrosion detection using a camera, okay, I would like to listen to some queries from the audience before I go to the corrosion detection using image processing techniques. Hello? Even you may speak out also, like I don't mind. Not only, if you have a longer question, you need not always type it. You may speak out.
You can unmute yourself and tell, no problem.
No issues. Actually, this session is supposed to be much more like interactive that way, but I would like to listen from.
Hello, Sainath.
Yeah.
I'm Siddharth. Actually, I'm also a scholar like you only. Like I'm also like doing predictive analytics. Like my research proposal is on. So, but now I think machine learning. There are a lot of techniques, but more are moving towards deep learning, I guess, in mechanical also. So, could you suggest some good topics so that also like in future we can work on, or I can also see something like related to deep learning in mechanical works?
See. Okay, fine. Okay, like although like I'm not in a position to suggest. No, I'm not in a position to suggest you, or I don't have vast experience.
Yeah.
So, but like general suggestion is that our approach in finding the problem is not like where is the problem, I will apply deep learning. That should not be the approach. At least it's my personal opinion. You may have your own perceptions, your own ideas. It is not like what are the areas I can apply deep learning. So in general, you try to solve some problems and whatever the tools and techniques that are required, that you apply. That can be a simple linear regression like y equal mx plus c, or even a classifier, or even a deep learning. So it should be the other way around. But we research scholars, I am also research scholars, I can understand the pressure of this publishing the papers, right? Publishing the papers, acceptance in the conference papers.
Yeah.
And of course, people give weightage to you. They hear the buzzwords like blockchain or even like deep learning. That is true, but like ethically or in a proper sense, what is the problem and what are the tools required for it? And then is deep learning necessary? That should be the actual flow. Okay.
Yeah, but I think you are working on visual. I think you are working on.
I'm working on visuals. That is true.
Yeah.
So now coming to the deep learning field. Okay. See, before answering about this Do you belong to the manufacturing field or industrial, like that sector? Mechanical.
Because I was working on predictive analytics in Microsoft Azure. I think there is a module predictive maintenance in Microsoft Azure. You know that?
Predictive maintenance, I mean, I know, I heard about it, and I
Yeah,
know
yeah.
which
But
is
it
equivalent
was
to what I'm doing only. Like, I mean, I'm doing just a
but it
small
was
part of predictive
like
maintenance.
a machine learning model which we used to apply. Like we used to take the data and
Yeah,
just put it on.
deployment. That I understand. See,
Yes.
deep learning. Let me say when actually deep learning is required. Deep learning is fundamentally required when you have a huge amounts of data. That is the first thing, first and the foremost. If your
Exactly.
data is small, okay. If your data is small, there is no question about deep learning at all.
Yeah. But
Okay.
as you
Yeah.
were saying about corrosion and all, I think that's on deep learning only, no? Like,
Exactly. See,
yeah,
in case of corrosion, when you say corrosion, in case of corrosion, there are multiple ways to approach at corrosion. People conduct laboratory experiments. They create artificial conditions, and then they measure using different equipments. I don't remember the
yeah,
terminology. They collect different kinds of data, different sensors data, MRR, like
yeah,
millimeter cube data, corrosion
yeah,
rate.
yeah,
So that's it, like using some electrochemical machining techniques. Okay, that is also a part of corrosion. That is also predictive maintenance. So if we are talking about images and
yeah, yeah,
especially video, since video images, the data like images that will be in like in gigabytes or even like terabytes.
yeah.
And if you want to classify, if you want to do so much of processing, those things obviously deep learning is required.
Required. Yeah, yeah, that is only. So,
Especially in images. Yeah. In other
yeah,
fields also it may be required. I'm not saying it is not required. But in general, where you have more images, deep learning is like it is generally applicable. And if you are
that's
aware
true.
of deep learning, there is something called convolution neural networks.
Yeah,
Okay.
CNN. Yeah,
CNNs. And
yeah, yeah,
in CNNs also there are so many variations, different architectures. So I don't want to talk
yeah,
about them.
yeah.
Okay,
That.
AlexNet, VGGNet, and many other things are there. And so yeah, so
Okay,
like
so it will be
yeah,
nice like if we can contact afterwards also regarding our discussion. We can take to a next level and all.
yeah,
So you please share me your email ID in this chat section after this one,
yeah,
so that
fine. I will share
yeah.
with everyone. I will share with everyone at the end. If they have any queries, they can ask me later as well. No issues.
Okay, okay, okay. Thank you.
Okay, welcome. Yeah. So one more query before I quickly go on to the okay. Oh my God! Somebody is saying I want admission PhD. Can you suggest me any time? So now R language and MCDM methods. See, I'm not in that position to for admission PhD. That is not my thing. But I will give you my
Can I interrupt now? See,
yeah, please tell me.
we can discuss those things later. Let us move forward for the corrosion part. Otherwise, we'll run short of time, and that part will be
Okay.
missed.
So like, what is the like?
So
How much?
after finishing that, we can have this type of discussions.
Okay. Fine,
Huh?
fine. No. Actually,
It is right, na?
I'm expecting some technical queries from the audience because
Yes, but we can take the queries later. Let us finish off the corrosion part first.
fine. Okay. So like, just one more thing, I would like to know like how much time more I have. Like, what is the general time schedule for the audience?
It is basically up to them. Means if they are interested, they can continue
No,
half an hour
officially.
or
No,
1 hour more, no problem.
I will be there, but I would like to officially what is the time? Officially, fine.
We have 15 minutes more.
Okay, we have 15 minutes more. Okay, in 15 minutes I will finish the corrosion part, and then maybe 10 to 12 minutes. After that, we will see how long the. It depends
Yes,
on the
yes,
participant.
yes.
Okay.
Hmm.
Okay, fine then. So what I will do now, although we have developed a very simple model, we will see in real life. Suppose somebody is asking me PhD. In PhD works, what we are supposed to do, how it looks like. Okay. So and for that purpose, I will take the corrosion problem, which is my own PhD work. Okay. So yeah. So you can say so yeah. Machine vision system. So machine vision system for inspection of corrosion. So there are two terms: computer vision and machine vision. So in simply saying, computer vision is like the algorithms, the hi-fi stuff in a crude way, the hi-fi stuff the computer science people and maybe the Microsoft, Google people deal with. They want to solve every problem and they will develop an algorithm and they will develop those things. And in machine vision, and what we do, we want to solve a specific problem. Suppose maybe the corrosion on a pipeline. or a value defect on a particular specimen, or a crack in a particular something. Are you getting? So we want a specific problem for a specific data set, a specific metal, in specific conditions. And that's what the machine vision deals with. Whereas computer vision is a broader field. It's a whole topic in computer science and ECD, electronics departments, where they generally tend for the generalized algorithms. So why is it required? Because you need to have an idea under what constraints your inspection goes. When I am saying this inspection of corrosion, I don't mean that, see, the most of the pipelines in the world, they are buried inside the, they are in the oceans, or they are buried inside the land, right? Inside the sand. They are not visible to you. So I'm not talking about inspecting those pipelines and they get corroded. I'm talking about the pipelines which are like which are exposed to the external atmosphere, and where it is in the form of rusting. I can see Fe2O3 XH2, where that can be observed visually. Okay, so that type of a corrosion I am saying. And when I'm saying corrosion again, so I'm talking about a metal, a steel metal. Okay, I'm not talking about silver. I'm not talking about copper. If it is copper, it is green. If it is silver, it is black. I mean, the corrosion colors change. So the constraints are so much important in the manufacturing field. So those are the most important things that will make your life so simple that you can apply a simple algorithm and say that you can really contribute. If in the beginning itself you consider all the types of materials, all the conditions, it's very likely that you are going to fail, especially if you're in PhD. Okay. Of course, I have made all those mistakes. That is why I'm telling you, and telling you some of the people. So you need to be very, very specific, narrow it down, and make it very, very simple. So this is the picture that the slide that you are showing, that you are seeing now, is a general step in any machine vision system. Suppose again, I am taking only two examples: corrosion and value defect. You have a camera here, and the value specimens are coming, and you want to detect it, and you want to develop the system as an expert in the manufacturing field, or maybe as a machine vision designer, as a production engineer. Suppose you may deal with those systems. So this picture clearly indicates all the necessary steps. The first step is the scene constraints, where you need to consider where am I dealing with? Am I dealing in the daylight, or in an industry where there is a noise, where there is a, what should I say, air is not so clear. Okay, there is a fog, or even like dust, because the lighting is not clear, the images won't be clear. You need to consider all these scene constraints, and then optical acquisition, and accordingly you need to purchase an appropriate camera. Purchasing a camera with the proper specifications is a tough job. It's not that easy. What camera to use, what resolution to use, whether it is a CMOS camera or a CCD camera, again which resolution, many things are there. Okay, so wide angle. So getting the specifications of the camera system itself again is a challenging task. And after that, once we acquire the images, somebody raised the talk about pre-processing, right? The pre-processing has to be done. Pre-processing is not all the time is all about the numerical data. Pre-processing may be as simple as discarding some of the video content, discarding some of the images, discarding some of the specimens manually. So many things like that. And then the segmentation. Segmentation goes like this. Suppose you have a camera, you have a specimen, okay? There may be background, okay? The background maybe some people may be there, or in the background some other thing may be there. If you want to make your algorithm efficient and simple, you want to take out that background. Take out the background, get me the foreground. Suppose you are looking at my image, right? So I am the foreground and that is the background. Okay. If you want some of the features of my eyes or nose or whatever, it may be helpful that you take out the background and then do some analysis. So with only foreground only, your analysis becomes simpler. So that is the segmentation part, image segmentation, foreground and background removal. Okay. And after that, the standard step is the feature extraction, and which we have done. In our simple example, we have done the feature extraction. For each and every flower, we have got 4 features: petal length, petal width, sepal length, and sepal width. These are the 4 features. It is the extraction of the features. And after extracting the features, you may need to do again some pre-processing. And then, with the idea you have in the machine learning algorithms, you will choose one machine learning algorithm. In our case, we have chosen K nearest neighbor. It is this step, K classification step. And then you will get some results, and then you interpret the results. If your model is working fine, you should be able to say, okay, my model is working fine. It is able to detect these defects because of this, because of that. That is the interpretation. And then once everything is set up, is ready at a laboratory level, and then you deploy it in the real time in an industry. So that is a general flow chart. Okay. So quickly, let me show you. So data collection. So this is some of the data that I have collected on in my own work. Okay, some of the images with the camera. And one thing is that I want my model to be so robust that even if there is a blurring, suppose camera is moving, it will be blurry, images will be blurry. And if there is a dust, it's not going to be so good. Or maybe some other noise, fluctuations in the current or some other temperature, sensor may get defective. Okay. So what I would like to do, I want to make a model which is robust to the noises, which is robust to the different environmental conditions. So what I will be doing is that I will be conducting, like I'll be inducing many defects in the images. Okay. So if you look at these images, I'm generating more data. If you look at them, they're blurred. You're getting uniform blur, Gaussian blur, and I'm also adding some illumination. I'm putting artificial illumination techniques so that my data becomes diverse, my model becomes robust. Whenever such a data comes, it will be able to detect the corrosion accurately. So there are different types of augmentation. So after this, I have got so many images. Okay, I think you may not be able to see all these things. So the first step in the PhD or even a simple problem is the data collection and then the feature extraction. So there we have 4 features for a normal flower, which are measured using some scale or some thread or whatever. For images, there are so much of literature. For images, you can have so many features like this. I'm not going to explain these features, but the fundamentals remain the same. You have to extract the features. And 4 moments, I think if you know a bit of probability, the one feature is, see, all of you know what is an image. Image is nothing but 3 matrices put together. 3 m by n matrices put together. 1 m by n matrix, second m by n matrix, 3 m by n matrix. 1 paper, 2 paper, 3 paper. If you put 3 papers together, R layer, G layer, B layer, there is nothing but an image. I think you know them. Image is a 3-channel network, color image. If it is a 1 channel, it's a grayscale image. Okay. So for these images, you have to extract some features. And how to extract and what are those features, that's a different topic. But similar to the example we have got, the 4 features, we have extracted so many features. And what I will do, once I extract the features, I will do the same thing only. I will do the same thing, like I will extract different features from RGB image, grayscale image. And then the second algorithm you can see in my slide, the KNN, is the K nearest neighbor algorithm. I have also used that algorithm also. And not only that algorithm, I have used decision tree algorithm, logistic design algorithm, support vector classification. You can have multiple classifiers. Among those classifiers, I will see which is giving the higher accuracy. Now you know what is accuracy of a machine learning model, right? For our case, we got more than 90%. For my data, for my features, I will check how much accuracy I am getting. And depending on the accuracy I am getting, the highest accuracy, that model I will choose with those parameters. So in this way, you will choose multiple classifiers. And after that, forget about all these things. Look at this data, training data and testing data. That is the same step everywhere, no matter what you do. You have some data, you have to split into training and testing. 80%, 20%, that is up to you. The rest of the part is very complicated and I don't want to discuss now. So the same thing I have also done, training data and testing data. And then this data I have given to these 4 algorithms. Which algorithm? Decision tree, k-nearest neighbor, logistic regression. And they gave their own accuracies. And after that, these are the different accuracies I got. Okay. So the green one indicates the testing accuracy. Testing accuracy and the bluish one. I did not talk about validation accuracy. I'm skipping it. So you can look at the testing accuracy and see which is the highest one. Here the maximum one. What is the maximum one? I can see the highest accuracy is only 83. Okay, so if I use different features, and if you know images also, I have used three different types of images. I mean, I have a normal RGB image, red colored image, red, green, blue, and I also have a grayscale images. You can say not black and white, it's the grayscale image, and I also have something called HSV, like Cartesian to polar coordinate system. Like we have XYZ, you can change it to polar coordinate system, right? R theta phi, or even cylindrical coordinate systems. Okay, R theta Z, R theta phi. Similarly, in images also you have multiple color spaces. So from one space to I transform to another space, and then after transformation and after doing all these things, the highest I got, you can see that here is the 0.97. If you see, can you see 0.97 at the end, the greenish one? The highest I got is 97, and that classifier is support vector machine. Okay, I have I have changed the different features, have changed the color spaces like coordinate systems. I have also changed the classifiers. After doing so much of shuffling, I got, say, I got around 97% accuracy. And this is everything is my PhD work. If you are interested, after the time I can speak about them. At the end, I can say for myself that a support vector machine has been designed by exploring various features. So many features. In the image processing field, there are so many features. I explored different combinations and different color spaces. And I got 97% accuracy, which is nothing but 3% error. So now this thing, what it does, what is the advantage of all this thing is that now you give me another image, I will be able to say whether there is a corrosion or not. Are you getting? Now let me talk about a bit of practical aspects. Please show slide number 8. Please click on the hide option. I don't know. I think I lost it. Anyhow. So yeah. See, although it is about a single image, the idea is that I am doing it for a single image. But the same thing, the frame. Okay. So if you have considered a video, a video is nothing but a sequence of frames, right? Suppose you have a 5-minute video. In 5-minute video, there will be so many frames. So each and every frame will be classified whether corrosion present or not. And if you want to go in detail, each and every frame will be divided into so many small parts. Suppose you have a bigger image that will be split into say 64 parts, depending on the size of the image, or maybe at least 16 parts. And each part will be checked whether in this part there is a corrosion present or not. And it will be done over like a 5-minute video or even a 1-hour video. It is like covering the whole plants. You have a drone, you have a camera attached to it, and that will keep on moving the whole plant or wherever is required. And then you don't need to go anywhere, you have to give it to the system. System will automatically say whether in which region, which location the corrosion present or not. Okay. So although I'm saying it in a much simpler way, this itself is a big project. The companies will deal. It's even a crores project. Okay. What I'm dealing is in PhD, learning the basic things, getting some idea what is happening, and playing with the different algorithms, and developing and deploying as much as possible and at a smaller scale. Okay. So that is my PhD work. And what I'm trying to convey, whatever the fundamental step that we have done, if you have some idea, if you become comfortable, the same philosophy goes to any classifier, any other things as well. And yeah, lastly, I want to say that these sessions, I have attended lots and lots of sessions in my 5-year span, literally around 40 to 50, not at least 40 sessions, 40 sessions, 40 workshops, 40 seminars. By attending so many seminars, so many things, you will get to know the tools. The resources are more important than the content. Now you can go back and look at such scikit-learn. You can go back and look at Google Colab, and you can go and look at NumPy, or even some other things, training, testing, the different technology I have used. Okay. So yeah, that's it from my side. And if you have any other queries, I'm very happy to. I'm very enthusiastic to answer as many questions like as you ask. So that's it from my side, and I would like to hear your. If you have any queries, please let me know. Yeah, please. If you have any queries, please let me know. Yes, confusion matrix. Exactly. See, this is just the beginning. You can use the confusion matrix. And from the confusion matrix, you can compute pressure, recall FN score. This is for simplicity. This is for simplicity only. Yeah, like the discuss. Yeah, we can discuss offline. Like if you have some personal queries, we can discuss offline. No issues. I mean, sorry. Like I need to give my email ID. So one of the participants has requested, right? So my email ID. Oh, so that is my email ID. Okay, and then my mobile number. I don't think. Okay, I'm not right. Fine. So I don't use my institute email ID so often. Please mail to uh, this one only. I just gave if you have some other official thing in the future, you may use that email ID. Please mail to like you can only use the Gmail thing. Once I ended up doing that. If you have any queries. And obviously, you'll be having one more session. Like tomorrow, I will have one more session on PCA, Principal Component Analysis. So, and there also we'll be using Google Colab. And like Professor Mahapatra has requested me to have hands-on session there also. And it will be a, like 40 minutes hands-on session. We will discuss more theory. I don't know how much if you are really listening to theory. We'll discuss more theory. What is eigenvalue? And I will ask fundamental question. What is a matrix? And we'll discuss few things like what apart from PCA, what are the techniques? But yeah, but I'm surprised to see that you guys are not asking questions. So I assume I don't know. That does it mean that the session didn't? I mean, it didn't help you so much. I have no idea. Generally, in these talks, like in these hands-on sessions, you will be having lots of queries, right? So, but nobody's asking queries. Like, okay, thank you. Yeah, welcome, welcome.
Okay, Sai. Let us stop here. We can start our session tomorrow.
Just maybe we can. I mean, maybe 1 minute. We can give 1 minute. I want to. I'm really. I should say I'm disappointed that people are not asking questions.
Okay. Okay, if you have any query, please ask. Actually, for the first time, we are doing this hand session online.
Okay. Yeah. Actually,
Offline.
hands-on sessions are not supposed to be online.
Yes, yes.
It will be much more effective if it is offline, but we have to go on with it in the given current scenarios. Well, then I'm okay. So don't hesitate. Maybe some people are hesitating to ask right now. Okay. If you have some queries, like you can mail me on my Gmail. I will be glad to respond. And even if you have queries, we can start in the beginning of tomorrow session or at the end of tomorrow session also we can continue. No issues. Okay. So yeah, I'm very happy to see that people are responding. And okay, sir. Then okay, we can hold on. We can. I mean, we can terminate it now if there are no queries. I'll call you in a while.
Yes, yes. We will discuss about tomorrow's session
Yeah, I'll
later.
call.
I'll call. Okay.